Sampling made simple. Understanding sample data and distribution. We were discussing the basic samples, selecting the samples, estimating points, distribution of the samples, sampling method, and the data errors. The basics. Sampling is about picking a smaller group, which is the sample, from a bigger group, which is the population of the same individual members, which are the elements of the population. Using samples to estimate and test ideas statistically without having to survey everyone saves time, cuts costs, and is more accessible. Selecting the sample. There's two populations that are to be considered, the finite and infinite population. A simple random sample is taken from the finite population, and every sample in that has an equal chance of being chosen. The second is a random sample, which is from the infinite population, and two conditions need to be met for those. One is the first comes from the same group, and second, each item is picked independently of the others. Estimating points. Point estimation is a statistical procedure which uses sample data to provide best guesses of the population. The sample mean is the point estimator of the population mean. The sample standard deviation is the point estimator of the population standard deviance, and the sample proportion is the point estimator of the population proportion. Distribution of the samples. Sampling distribution is the basis of statistical assumptions because it helps calculate things like standard errors, confidence intervals, and test results. According to the central limit theorem, the sampling distribution of the means tend to look like a normal distribution as a sample size gets bigger. There are two distributions that we look at. One is for the sample mean and the sample proportion. The sample mean varies around the population mean, and it approaches normal distribution as the size grows. The sample proportion varies across samples, but can be modeled to estimate population proportions accurately. Larger sample sizes reduces variability and standard error, which improves precision of estimates. Finding the average weight of Boston Terriers is an example I have included. Let's say we took a simple random sample of 9 adult males in Prince George from the heart, and it showed that they had a mean weight of 25 pounds, well, average weight, and standard deviation of 3 pounds. So to look at the 9 Boston Terriers, we have a sample mean weights of from 22 to 28. To get the Z scores, you would have to subtract 25 from 22, and go down the list, and then you get your Z scores, which you will have to look up the probabilities on the Z score tables. This just basically shows that the average weight of the 9 Boston Terriers are like in close range of the average weight of Boston Terriers of 25 pounds. And it will be mapped out on the bell curves. I'll show you which intervals it's closest to, which percentage. Other sampling methods. I have included 3 sampling methods here. One is the stratified. An example would be surveys by age groups. The second is the cluster. An example would be a city block traffic study. Third is the symptomatic, and an example of that would be quality control in manufacturing, big data, and standard errors. When you have a lot of data with big sample sizes, your estimates get more precise as the standard errors go down. With more data, the stats become more reliable, and you could just spot out the differences. But you could still have issues with it, bad data quality, heavy computing needs, and biases. If used correctly, big data tools can give you detailed insights and help you make more solid data-driven choices. Summary: sampling is about choosing a small part of the bigger group because it's easier to gather and analyze the data. Estimation uses that sample data to make good guesses about the group's average or variability. In real life, sampling and estimation help save money and time in things like business surveys or public research. Knowing about the sampling and estimation is pretty important for understanding data correctly and making good decisions. Thank you.